Hey everyone, Adam Simmons here from DGTL Infra, short for Digital Infrastructure. Starlink is live and ready to be used by the general public, with SpaceX having deployed nearly 1,000 Starlink satellites into orbit. In part 2 of this two-part series, I'm going to give you an overview of Starlink's deployments to date, as well as a launch plan for the future, explain how Starlink works, discuss what Starlink can offer you in terms of speed, latency, and capacity through its public beta launch and into the future, and finally show how all of it ties back with digital infrastructure. You will gain a clearer understanding about the details behind Starlink, what it can do for you, and how it affects our planet entirely. So stay tuned and I'll break this all down for you. Before I do, be sure to subscribe to the DGTL Infra channel and turn on the notifications so you don't miss my next in-depth video that is coming out soon. Now, let's jump into the video. So in 2019, Starlink deployed 120 satellites over 2 successful launch missions. And Starlink is deploying satellites with reusable rocket booster technology, the key word being reusable. Furthermore, it is the only company with the capability to recover and reuse orbital rockets. The first stage boosters actually land back on land or at sea on SpaceX's autonomous spaceport drone ships. At present, SpaceX has deployed 955 Starlink satellites into orbit, with plans to have over 1,000 satellites in orbit by the end of 2020. Starlink is doing an additional launch every 2 weeks using the reusable Falcon 9 rocket and launch system. So you can think of every Starlink launch as bringing 60 satellites into space, and each launch occurring every 2 weeks, meaning about 120 satellites are launched every month. And overall, in a year span, that is equivalent to launching about 1,500 satellites per year. If we look on screen, this is the Falcon Heavy launch profile, and Starlink could also start to begin using SpaceX's Falcon Heavy rockets, which are the most powerful operational rockets in the world by a factor of 2. They have the ability to lift into orbit nearly 64 metric tons, or 141,000 pounds. That translates into a payload of approximately 250 satellites per launch instead of the current 60 that are being launched on the Falcon 9 rocket. Additionally, SpaceX's Starship spacecraft and Super Heavy rocket could also be used once ready, and they can carry 100 metric tons to Earth orbit and a payload of approximately 400 satellites per launch, compared to the Falcon 9 at 60. So the reason why Starlink and the LEO satellite internet service provider's solution has grown so much interest is being driven in part by cheaper satellite costs, but mainly by investment in rocket technology. And this is specifically attributable to reusable rocket technology, which allows for a lower cost for each launch that Starlink does. Specifically, the advanced heat shield technology provides far more durability on re-entry for the reusability of those rockets. Elon Musk has the goal of flying reusable rockets twice within 24 hours, and this will help to avoid the scenario where most of the equipment is discarded on each mission. So another critical aspect about Starlink to understand is how it works, and also how it ties back to digital infrastructure. Satellite broadband networks use their altitude of deployment and wide coverage area to bring global internet access from space to areas underserved by terrestrial networks. If we look at the satellites at the top of the video, they are launched into space via rocket and positioned into the low Earth orbit, or LEO, satellite constellation. They facilitate two-way broadband service by simultaneously sending data to, as well as receiving data from, the ground station, which is seen at the bottom left of the video, and the user terminal, which is seen at the bottom right of the video. So let's walk through Starlink's 3 main components. First being the user terminal, which is at the bottom right of the video. The user terminal is a small satellite dish, about 1.5 feet in diameter, that sits outside the user's home. It is electrically steered to ensure a connection with the appropriate satellites moving across the sky. It requires only a simple installation with no technician needed. Simply point it at the sky and plug it in. However, the terminal does need to be placed outdoors and outside the house, and requires a direct line of sight to the sky. To reach the internet, the terminal will send its request to one of the satellites crossing the sky, which we'll talk about now. So if we look at that satellite at the top of the video, the satellite will use the Ku band and eventually the Ka and the V band spectrum to process this request. The primary frequency bands licensed to satellite networks are in the Ku band, which is 12 to 18 GHz, the Ka band, which is 27 to 40 GHz, and the V band, which is 40 to 75 GHz. These bands have been identified as the frequencies with the resources and throughput best suited for transmissions via satellite. The satellite in turn beams the instructions to a ground station, which is thought of as the brains of the system. That ground station is at the bottom left of this video. The ground station is connected via fiber and is in close proximity to a data center to connect to the internet or to a cloud on-ramp. So just to emphasize the importance of digital infrastructure, which this channel is all about, we note that specifically the fiber and data centers are enabling satellite connectivity to the internet. Starlink has more than 50 ground stations throughout the United States, and will be building far more over time to reduce latency. Once instructions are received by the ground station, meaning that the website has been reached, the process is reversed as the ground station then sends the necessary data to the satellite through what is known as forward uplink, and then back to the home terminal through what is known as forward downlink. The satellite provides both the front haul to the home and the back haul to the data center. So now that we understand how Starlink works, let's talk about the public beta test of its internet service. So on October 27th, 2020, SpaceX expanded the beta test of its Starlink satellite internet service to the public for select users that had expressed interest. Prior to the public release, SpaceX conducted a private beta test with its own employees. But now that the public beta test is live, Starlink's service is priced at $99 per month and includes a $499 cost to order the Starlink kit plus a shipping fee of $50. What you get in this package is a satellite dish, which you can think of as the user terminal, which we just discussed, a tripod mount, some cabling, and a Wi-Fi router. Users are told to expect to see data speeds from 50 megabits per second to 150 megabits per second, and latency from 20 milliseconds to 40 milliseconds over the next several months. However, some speed tests for beta users using Starlink's broadband service in actuality are seeing download speeds closer to 11 megabits per second to 60 megabits per second, and upload speeds of between 5 megabits per second and 18 megabits per second. The public beta test is really trying to target the small set of subscribers in the United States that have little or no internet connection. But obviously it's also being used by some people who just want to test out the service. Starlink is currently offering the service with no data caps or contracts, and states receiving the service are primarily northern states along the Canadian border. So what will Starlink offer in terms of performance? It's touted as high-speed, low-latency satellite broadband to any location on Earth. And so we just went through the public beta, but once fully developed, Starlink will be much improved. And so let's go through some of the targets now, which Starlink is seeking to achieve. So as you can see from the right side of the video, in terms of speeds, Starlink has been tested numerous times at over 100 megabits per second download speeds and over 40 megabits per second upload speeds using the standard user equipment. In terms of latency, the satellite latency is driven by altitude, so given that Starlink is a LEO constellation and close to Earth, the latency is reduced. SpaceX's system can deliver high-speed broadband at total latency below 40 to 50 milliseconds, and it's really enabled by operating those satellites at 550 kilometers above Earth in orbit. Starlink's target in terms of latency is to be below 20 milliseconds, which is ideal for gaming, and then over time be even below 10 milliseconds. And as you can see from the right side of the video, the ping, which is a measure of latency, in these tests was all below 20 milliseconds. Finally, capacity and network throughput is very important. Starlink's phased array antennas allow the system to automatically steer beams to optimize service to certain locations. The system can dynamically adjust its capacity in certain locations to match consumer demand and regulatory requirements. Each satellite in the SpaceX system provides aggregate downlink capacity to users on average of about 20 gigabits per second. So therefore, each launch adds about 1.2 terabits per second of capacity, assuming that the typical launch includes 60 satellites in a Falcon 9 launch of about 20 gigabits per second on average per satellite. So once Starlink's 11,943 satellite constellation is built over the next 6 to 7 years, so think by 2026 or 2027, the system will be able to serve about 500,000 simultaneous United States households with speeds of 100 megabits per second, and that's its total capacity. However, not all of those customers will be online at the same time. Therefore, if we assume a 4 times oversubscription rate, it implies that 2 million households in the United States could be offered Starlink broadband services. So if we compare that 2 million household addressable market for Starlink to some of the largest United States cable providers, which have significantly more subscribers, it puts it into perspective Starlink's target market. So Comcast currently has 30 million broadband subscribers. Charter Communications currently has 28 million broadband subscribers, and AT&T has 15 million broadband subscribers. So all of those companies' current broadband subscribers are well in excess of Starlink's entire addressable market of 2 million households, based on the capacity that the satellites can serve broadband connectivity. Finally, it wouldn't be DGTL Infra without talking about digital infrastructure. So Starlink has a number of touch points as we described with fiber and data centers before, but let's talk about a couple more right now. So in mid-October 2020, Microsoft announced that it is collaborating with SpaceX to connect Starlink's network to Microsoft's data centers, including a new Azure modular data center service. The service will be used for customers that need cloud computing capabilities in hybrid or challenging environments like remote areas. This service really builds on Microsoft's earlier rollout of Azure Orbital, which is a platform that processes data from satellites and provides ground station communications as a service. Moving beyond data centers, a key theme in digital infrastructure is 5G. So what does Starlink mean for 5G? So satellites serve that wide area of coverage and bring worldwide services to areas that are still not covered by traditional optical fiber, fixed line, and wireless networks. So they really complement the 5G convergence. So satellites offer resilience in internet access, which is mandatory for 5G use cases such as autonomous driving, which we spoke about in our 2 prior videos, emergency medical systems, and the Internet of Things. The role of reliable and ubiquitous satellite access is an integral part of existing fixed line and wireless networks for bringing connectivity to everything in 5G. Satellite networks combine the data transmission via wireless 5G and cable networks so that everything is in communication. And given the limited coverage of towers that you see at the top and middle of this video, satellites are used, which allow for long-range transmission and are not constrained by the physical limits facing a cable network to provide connectivity in uncovered areas. So hopefully you found this video and our 2-part series on Starlink helpful. If you did, then please share it with somebody you think might also find it helpful. and consider subscribing to DGTL Infra, and visit us at dgtlinfra.com for more of the latest news on digital infrastructure. Thank you for watching this video. Be sure to like the video and post in the comments telling me whether you think you would be willing to try the Starlink public beta test once it becomes available in your area. Thanks again for watching, and I'll see you in the next video.